Well, it's close. Hello and good morning. So welcome back to the rebuild of Little Lauren, engine 2959, the Wallis Steevens 8 nominal horsepower expansion engine. We're back working on her holes. Got to sort out Lauren's holes. Just getting ready really to get set up to do some line boring. So on the last episode we got the actual box housings cleaned up, got their register cleaned up trim. We done that in the little Kearns boring mill. This week I want to get set up so that when we come to do the line boring, Mr. Buckham of Onward Engineering can get his bar set straight up, register with these holes, and then we can go straight to turning these out, welding them up, and then reboring them to size. So all I've got to do, all I want to do, is I want to get a plate in there like this. This is one of the plates that we use to line up the cylinder with our alignment bar, 40mm hole in the middle. So what I want to do is, if this was a little bit bigger we could use it, but it's not, so we're going to make 2 more plates like this, and all this is going to do is it's going to locate our boring bar, our line boring setup in the center of this existing hole. So it's basically just an easy way to locate your bar before you do your boring work. So I'm going to go in and find a bit of plate, fire up the plasma cutter, rough cut them, machine them up, and get them in there ready for when he comes to do the line boring. So that's the first job of the day. Let's get the plasma fired up and start doing that. Right, so we're going to go shape manager. What we want is a flange, and then we're going to do 285 OD. The inside is going to be 40mm finish. So if we do that at 35mm, lead in 1mm, 1mm. So that should basically be our part. Quite a simple job. Going to want to find the center of the plate. So that's 300, so 150 is about there. And then 150 in, right there. Got our little laser on. Right, let's try that. As you see by the sparks coming back, that's too fast. So we'll slow that down. An amazing cut quality, just want to get it roughed out. So that first one was pretty bad, so let's change a few things up, see if we can get that a bit better. I put a new tip in, being the main difference. Let's try that again. God, it's heavy. There you go, that new tip made a world of difference. Pretty decent cut off that machine, even though it's probably 20 years old. Right, so we got our setup on a Duno, rapid drilling machine. What we got is a quite battered 1 9/16", which should be just under 40mm, and then we've got this monstrosity that someone built one day. Obviously they wanted to put it in a drill chuck, hand operated battery drill chuck. So that's a 40mm reamer with a 13mm shank. So that's what we're going to ream it out to, 40mm. I do believe the boring bar for the line borer is 40mm. Not too happy about sticking that in the spindle, to be honest, but it's the only one I got. So those of you that ain't familiar with the Duno, this is what they call a rapid drilling machine, so you can put it to where you want it, lock it off, and then it goes solid. Basically just a radial drill, but like a more modern equivalent. Glorified drill press. So we get that somewhere in the middle. That's it. I'll rinse and repeat with the other one. There's a bit of the bar we use for cylinder alignment, so that should slide on, no bother. So there's your basic principle. All we got to do now is make these a nice fit in the horn plates. And then that should be set up in the engine. Then when we come to do the line boring, this will be substituted for a boring bar, and then the motor and everything on one end. So let's get them chucked up and turn the OD. Right, so we need to get a rough idea of what we need size wise. Obviously this is very rough surface in here. There's not really many places you can take a decent measurement from. So we are just going to have to do a little bit of guesswork. Just check that. 275/75. So I'm going to take that measurement from a few different places. Just take a bit of an average, really. So yeah, that's 27495. So it's about a mil of outer round. So I'm going to figure out what the smallest dimension is. And that's what we make our OD of the plate to. Right, so we're set up in the Almighty Chipmaster. Just got it in a 3-jaw chuck, grabbing it on the inside, so that our ID should run concentric with our OD. We just need to get down to 2735, or would have been 10 inches, I suppose. So let's so as you can see, we're always right on the limit of what we can do. I don't think we get much more swing out of this machine, but it should be just enough. You see, just up against a 3-jaw chuck, got a compound swung round. Give us the reach, we should be able to skim this back edge. Of course, there's always tight quarters in here. It might be in the way a bit, but we want to be out of the way of this coming out, really. Right, that's got her bogging down a bit. over low gear. Wow. Right, well, I wasn't happy with how much of a hold we had on that, so I've gone ahead and we've put basically a drawbar through the spindle to the other end with this big clamp. I think if we tighten that up, there's no way that can come out now, so I can safely stare at it like this without worrying. But yes, it's not like in cutting it. I got quite a positive rake insert in there. I might try something a bit different, but I've slowed it right down. Now we're in bottom gear. You can't hear a lot when this variator's running on this Chipmaster, so I'm just going to plod on and see if that makes it better. There you go, that made a world of difference. That's the way to do it. That's the way to do it. So we are to 790. So we're at 2790, we want 240.36, although that's bigger there. What's happened? There's 27980, so 27980. Right, let me crack on a minute. See if I got a mic that big, really. Right. Right, so that one, right, so once we got that clamp on there, that works out surprisingly well. That's the way to go. So we should be somewhere. We're at 27439. So when that cools down, that should be spot on size. So as to whether it'll fit in the horn plates is still yet to be decided. So let's whip it out and try it in the engine. It's a good finish. Finish right on size. What we were shooting for. Obviously this doesn't need to be as accurate as we're making it. There's plenty of room for play in the back axle. But as always, we want to try and get it as nice as possible. It's all done a nice job once we got it. Fucking thing. So it's all done a nice job once we got it to stop ringing. Main problem is getting through that the hard heat affecting zone. Right. Right, so this is the side that's the most round. Let's get rid of the most of the high spots. Let's see if our plate will fit in. I put a tiny little lead on the corner of this plate just to help us get it started. As you can see, that's going to be a nice fit. It's just hanging up on the bottom, I think. So it's blatantly obvious how out of round it is with the fact that it's hitting on the top and bottom. You get the idea. That's going to, if I can get it in there square, that's going to give us something to line up on. So I want to start. Right, so I've got that plate fitting in this side nice. I'm going to make the other side slightly smaller, save us having to fight it. But that one's pretty much in this side. Try and get it flush. That's exactly what we wanted. Nice tight fit, nice accurate location of the centre of this hole. So I'm happy with that one. I'm going to make the other one just, 0.1 mil smaller. And then that should fit the other side. Nice, right. Right, let's get on with number 2. So we should have finished this one a little bit undersize of what we figured the last one was. So let's go try it in the engine, see if that made it easier. There's no need to have it as tight as the last one. So let's go have a look. Alright, I might just bring the chucking reamer in the drill chuck and clean out these bores as soon as they've had a bit of a butchering on the lathe, and we'll chuck our alignment bar through. There we go. So all you need there, take the eye spots down. We'll go grab the bar and we'll see if it lines up. There, that should work. Perfect. So for those that are still wondering what it is we're doing, this is basically just an alignment tool that we've made up here today. So it's for when we reclaim this hole, we want to make sure that our new hole is in the same spot as the old hole, just so that we're not going to have any issues down the line. So this plate is what it's done, is it's located our boring bar, which is going to be our boring bar, in the centre of the existing hole. What we come to do is when we come to do the job of line boring and welding these holes up, is we'll mount a bearing an outboard bearing with some steel straps to keep it in location, and then all this would be removed, and then we'll be relying on then this bearing being in the middle of this bore. We would then take a cut, clean this up. Long'un's got a bore welder, so we mount his bore welder up, and he will put a couple of MIG passes just round in the plates, just as build up, and then we'll cut that back to suit our axle box housings that we've machined on the last video. So a rather simple yet effective way of doing it. If I can convince Long'un to let me film a bit of it when he's doing it, we'll get some footage of it. But so that's about as far as I can take it. I'm not going to be holding him up now, so it's all ready for when he gets a chance to come around and do it. So that should be an interesting little job. Little insight into reclaiming bores. Of course, there is always other ways of doing it. You can clock this in with adjustable bearing mounts and things of that nature, but this is the way I like to get it set up. It seems like you can't go wrong, really. It might give us a chance to put a bearing in the middle if we need to, but that'd be down to Onward Engineering and his expertise. So that'll be coming up soon, but that's as far as I can go with it today. So the next job I can do is, once we get the axle box located in this hole, I would like to ream all these holes out to match the new location of it, which should be the same as the old location, but it's going to have a little bit of variance. So I'd like to make some dowel bolts so that we can hold. So I'd like to make these nice dowel bolts so that it's going to be located on this plate, and it's going to be held solid. This plate will then give the broken casting a little bit more support, and stop it twisting or moving or anything, down the line. So I want to get these all to be locating dowels as well as bolts. So I think the next thing I need to do is remount all the holes in the axle box housings, so that they're ready. Then we can use them. Once it's all mounted back up, we can run a reamer through, and then it'll all be as one. So with all that being said, I'm going to make that do for this week. I got a few other jobs I got to do before I can get them axle box housings mounted in the drill to ream them out. So yeah, a little bit more work done, and we'll keep plodding on. So I'll see you on the next one. Cheers.